Hello, I'm Mr. Singleton. I'm one of the Associate Directors of Science for Outward Academy Dagenham. This lesson is all about this equation which is found on the specification. Uh, Fortunately for you, this equation is on the equation sheet that you will be given in the exam. So you don't need to learn this equation, but you must be able to apply it. You must be able to rearrange it. You must know all of the units, etc. So you need to be aware of it. So that's what this lesson will be covering. Before we start, there is another equation when we talk about acceleration that you should have learned, and you should know also the other equation for speed. So there's two equations that you're going to need to remember to answer these questions, and the one is for speed and the other one is for acceleration. So these are two that you need to be aware of. I want you to try to use them two equations to answer those two questions. They are fairly simple questions. You shouldn't really need to calculator or anything like that. As long as you know the equations, you should be okay. I'll give you 1 minute on a whiteboard or on your piece of paper if you're working from home. Off you go. Okay, I'm going to help you out a little bit here. So to work out speed, it's distance divided by time. So you need to look at which one's the distance in that first one and divide it by the time. And then to work out acceleration, you need to do the change in speed divided by time. Okay, let's go through some of these answers. So you should have done 10 divided by 2, which is 5. So that gives you 5 meters per second. And then for the next one, you have to work out the change in speed. So you should have 10 minus 4, which is 6, and then divided that by the time, which is 2. So 6 divided by 2, which equals 3, and it's meters per second squared. So what I want you to do now is make sure that you're well away from any distractions. Make sure you've got a pen and paper ready if you're at home. If you're not at home and you're in school, make sure you have your book ready and you are ready to learn. Here is your title for today's lesson. It's called Equations of Motion. That needs a date at the top underlined with a ruler and then your title underlined as well. I'll give you 1 minute. Off you go. So our challenge today is to calculate the final velocity using an equation, just one of the equations for motion. And our aspire is to be able to manipulate and rearrange the equation of motion to calculate any of the quantities which are in there. So it's that equation that I showed you right at the start. So there are a couple of equations for motion, and one that you've already used, which was the change in speed divided by time. And then there is this one as well, which you need to remember. Now there's 5 symbols, which is SUVAT, so they are called the SUVAT equations. And in this equation that I'm going to talk mainly about today, this one doesn't use t, doesn't use time. So this is the one, if I was you, I would be writing down at this point in time and making sure you know what each letter means, because this here is all you are going to get in the physics equation sheet. So you need to know what each one is and how to use it. So V here is velocity. And u is the starting velocity. So this is the final velocity, and this u here is the final velocity. And this little 2 up here obviously means squared, and that is equal to 2 times the acceleration times by s. Now s is an interesting one. It means displacement. It means the overall distance traveled from a starting point. So they use the letter s for distance, which is not its displacement really. It's the overall distance traveled from a point. So this is the equation. Please make sure you've got it written down. I have put it onto the slides just to help you, but it's great to have it in your book so it's there in front of you or on your paper. Okay, a little bit of a check then, see if you can remember these ones in this equation. What is V, what is U, what is A, and what is S, because you need to know those. So I want you to answer those in your book, just a 1, 2, 3, 4, or on your whiteboard if you want. 1, 2, 3, 4, what do those letters mean? Off you go. Okay, let's go through some answers. So V is the final velocity. If you haven't got that, please make sure you've got a note of it. U is the starting velocity or the initial velocity. A is acceleration and S is displacement. The unit for that will be a measurement though. Remember, it'll be like meters or something along those lines. I'll give you 30 seconds just to write those in so you've got them. Okay, so when we are talking about this equation, and if the questions say initially at rest, that means you would use, that means initially starting, it's at rest, which means it's not going anywhere, it's not got any speed, therefore, or velocity, therefore it's zero. Okay, so if it says, if the question says initially at rest, u is going to be zero. And if you end up with a negative number for your acceleration, remember that's okay, that just means it's decelerating. So don't be worried about it being a negative number, it just means it's slowing down. Sometimes you can do a bit of a sensibility check. If the question says the car is slowing down, you know you're going to look for a negative number to make sure you've done it right. Okay, so here is a worked example. So question, let's say this is the first question you come to. A car is traveling along a straight road at 8 meters per second. It accelerates at 1 meter per second squared for a distance of 18 meters. How fast is it traveling then? So that's basically I said, as it accelerates, every second it's going faster by 1 meter per second. Okay, and it does that for 18 meters. So the first thing, you've got to get these right, and this is the same for every physics equation. Write out the equation that you need, because you might get a mark for that. Substitute in your mum numbers, you will definitely get a mark for that. Rearrange it if you need to, you'll get a mark for that, and then work it all out and add the units. So this could be a 5, a 4 or 5 mark question, could be a 6 if depending on if you were using another equation to get some answers. All right, so step 1, here we go. Number 1 on there, I've written out my equation, b squared minus u squared equals 2as. And that is straight off the equation sheet. But it shows the examiner you know which one to use. All right, so it's important to write that in. Now you're going to start substituting the numbers. So you have to know what u is. Look at your piece of paper or your book. U is the starting speed. Okay, so you're going to use this 8 meters. So you're going to put 8 squared in there. So you've got v squared. We don't know how fast it's traveling at this point in time. And that's what we're trying to find out. So we can't find v squared, but we do know what its starting speed was, 8 meters per second. So that goes in there. Now we put our equal sign in, and then we do 2, and that's straight off the equation, 2as. So we're using that 2 there, times by 1, because 1 is a. The acceleration is 1 meter per second squared. So we're going to put that into our equation. And then s, remember that's the displacement, all right, which is 18. So you put that into there. I would then, because I just like it to be nice and neat, I would then work out all the bits that I need to. So 8 squared is 8 times 8, which is 64. And then 2 times 1 is 2, times by 18 is 36. So there is my starting of my substitute. There's my substitution, and I've just worked out to be a bit easier. Now, when you are doing this in maths, you should be taught this way, and we try to teach it this way in science. And this is why we don't use triangles anymore, because a triangle would be very, very difficult with this equation. So whatever, I need to get this side of the equation. See this bit here where it says v squared minus 64. I need to get that just to be v squared by itself. So, well, how do I do that? If I've got minus 64 and I add 64 to it, then that equals 0. And now I've just got v squared by itself. Whatever I do to this side of the equation, I have to do to this side of the equation. So I've added 64 on this side. I have to add 64 on this side. So I've just made this a bit easier again for myself. Now I've got v squared, because I've got 0 over there, equals 100, which is the 36 plus 64, sorry. Now I need to do the inverse of squared. Well, how do I get rid of that squared? I would square root v squared, which would then just be v by itself, and then have to square root this side, so square root 100. Now I've got v equals 10, and then I must remember my units, which is meters per second, because it's a speed. Okay, that is how you would work out how fast it was traveling at the end. Please remember this bit, so important. Write your equation, substitute your numbers, rearrange it, then work it out. Why do I tell you that? Because if you write the equation and then try to rearrange it and you get that wrong, then you've lost all the marks apart from maybe that 1 mark for remembering the equation. If you write the equation and you substitute the numbers, you've already picked up 2 marks. If you then rearrange it wrong, okay, you've lost out on that, but you haven't. But you've got 2 marks instead of 1 mark. Substituting is really easy. Okay. So I want you to have a go at this question here. So a cyclist is traveling at a constant speed of 4 meters per second. She suddenly accelerates at 0.45 meters per second squared for a distance of 9 meters. What is her final velocity? I'll leave that one with you for 2 minutes. I will help out at about 1.5 minutes if you're really struggling. All right, off you go. Have a good go at it. Okay, I'm going to help you out a little bit. So the cyclist is traveling at a constant speed of 4 meters per second. That, remember, is the starting speed, the initial velocity. So that is going in place of u. Okay, then you've got your acceleration, which is over here, which is 0.45. You're going to do 2 times 4.5 and then times that by 9 because that's the displacement. All right, so you've got to work this bit out and then you'll be able to carry this over. Remember, you've got to do 4 times 4 or 4 squared. So you'll have 16 here, okay? And your answer should end up being 4.9 meters per second. If you got that answer on that last slide, then you're doing a great job and well done. This is more like a 6-mark question, but I've split it up a little bit for you just to make it a little bit easier. So in this point, you're going to have to use 2 equations. You're going to have to use acceleration equals change in velocity divided by time, and then you're going to go on to use this bit, because once you've found the acceleration, you can substitute that acceleration into this equation, and then you'll be able to work out the distance traveled. So remember when we talked about a car being stationary, that means that your starting velocity is 0. So you're going to use 0 for that, and then it has a constant acceleration of 2 meters per second squared, and it's doing that for 10 seconds. So what you've got is you've got its acceleration here, you have got the time, you now need to work out the change in velocity. So I'll let you work on that. I'll give you 5 minutes because it would be a 5-mark or 6-mark question. Once you found out part A, then you can substitute that in to part B and try to work out this S here because you're trying to work out displacement. So you've got 5 minutes, off you go. Okay, so for part A, what you should have done is acceleration equals change in velocity divided by time. Now we don't know what the change in velocity is, so we'll have to substitute that for v. So then you've got your acceleration, which is 2, equals v, which is the velocity that we are looking for, divided by t, which is the time. So then to get rid of the 10 over here divided by 10, you would times it by 10. Whatever you do to this side of the equation, you have to do to that side of the equation. And then because the car was initially stationary, it's going to be 0. So then you've got 20. All right, so v is 20 meters per second. Now you can use this to substitute into your other equation. So you've got b squared minus u squared equals 2as. And this time we are looking for the displacement here, which is s. So we've got b squared, which was 10 from our other, which was 20, which was from our other answer. And then we minus 0 squared, which is then just 0, times by 2, times 2 equals s. And then you can just follow that on until you get s. So that is how you would complete that equation and that question. All right, so plenary now. You don't need to do a revision card for this one because it's teaching you a skill of using that equation. So this is the last bit of the lesson. I want you to use this equation, and again, I've put it on the slide for you. All right, an airplane has a maximum acceleration of 6 meters per second squared. Calculate the minimum length for a straight runway so that the airplane starting from rest, so that will be 0, hint hint, can take off safely at a final velocity of 90 meters per second. And that would just be a free mark question because you are just substituting in those numbers, then rearranging in order to get this length, this displacement again. So I'll give you 3 minutes and then I'll go through the answer and then you have finished this lesson. Okay, 3 minutes, off you go. Okay, you got 1 more minute. Okay, so your answer should have been 675 meters. Great work if you managed to do that. If you're not sure on anything, please just go back over this PowerPoint and double check it all and go through the calculations again. Well done, guys.